Now, this is an important slide, the scheduler object rogues gallery, as I call it. There are three primary components to the Oracle schedule. There's actually more than three, but these are the core or central three that I really need you to understand. First, there's the job. The job is formally defined as a collection of metadata that defines a task. And yes, you can get really complicated with this and do conditional logic and all that, but we're going to keep things simple in this module. Once you have your sea legs, so to speak, in other words, once you understand the fundamental building blocks and you've mastered that, then it's time to move to the more complex stuff. I like to define a job as a container object into which you can plug in programs and a schedule. Now, of course, we haven't defined a schedule or a program yet. Hang on to your hat about that. But the best practice is to actually work backwards to what I'm showing you in this slide. In other words, build out your programs and schedules first, and then create your jobs. So the job consists potentially of a recurrent schedule. It consists of one or more tasks, specific things, and these could be PLSQL blocks or OS shell scripts, like I said earlier. And you can also attach additional metadata to the job, for instance, runtime credentials. On a local Oracle server, by default, the job is going to run in the security context of the owner, the schema object, the user, the Oracle user who created the job. You also can do local or remote destinations. The destination is formally defined as the target system on which the job will run. Now, the schedule is a container object or just a database object that defines when and for how long a job should run. You see, both of those are important. One is scheduling how often. Maybe it's just a one-time schedule or a weekly schedule or a daily schedule, but you also want to specify how long you're allocating that job. I mean, let's look at it. Multi-user databases like Oracle are all about resource allocation. They're all about concurrency and doing what you can to juggle multiple concurrent sessions that all are trying to do things on their own schedule. Finally, we have the program, and the program refers to a discrete unit of work that could be a PLSQL package or a Java procedure. It could be an OS shell script. It could even be an external executable program file. It's neat that the scheduler system is modular such that you can create individual programs. Maybe you have a program that's a script that performs an RMAN database backup. Why is that cool? Because you might have different jobs that run on different schedules, and you may want to reuse that particular program. Do you see what I'm saying? You might create a complex schedule that runs twice a month during a particular time period, except for holidays, etc. You don't want to repeat that schedule for every job that consists of that runtime environment, right? No. So you'd create the schedule once and then reuse the schedule object in your job. That's why I think that best practice is to create your programs and schedules separately and then plug them into jobs as modular units. It's all about avoiding reinventing the wheel and taking advantage of code reuse.